So before I was talking about how I want to design a better gear system that could give all these advances that are available adjusting, and you could adjust for more parameters, and adjusting is smooth, it's stronger than a traditional gear system with less wear and tear. It could give you more torque and speed, more precision and accuracy. It could disengage and fit more, and in some ways it could be more energy efficient because you could lower the weight of the box, less frictional loss of energy and stuff. But there was also huge problems with this whole thing, in that the waves I've talked about making with the piezoelectric ones are pretty inefficient. Now they're a very small part of this overall system, but they're still pretty inefficient. To give you an idea, is that papers usually call around 25.3% efficiency for a piezoelectric motor. To put this in perspective, there's many other types of motors. Like a good car engine is like 10 to 30% efficient. So that's not that much. And a car engine, I'm talking about the internal combustion engine, you have to pump the oil and gas over long distances, so it's even worse than that, and you have to process it. Electricity just flows easily throughout an entire system. So that's not as bad efficiency as it sounds like, but still pretty bad. But if you look at an electric motor, the typical one, not piezoelectric ones, powered by with magnets, with electromagnetic interactions, and that there's many different types. They're very complicated. Induction, permanent ones, non-permanent ones. The efficiency is way greater. For a very inefficient one, it's 78.8% efficient. A lot of them used in electric cars are over 96% efficiency, and high efficient ones are 98 to 99% efficient. A lot of that loss is due to the magnetic field, is due to resistance in the motor, which heats up the motor, and a lot of it's also due to not only resistance with the motor, but you also have the magnetic field interacting with other stuff outside the motor or electric field. So like you magnetize a little bit of stuff, and that leads to hysteresis loss. Other one is due to friction within the motor. But I have a way to take this, but still with all that, it's still 3 times or more efficient than a piezoelectric one. And if it was fully, and so how can I incorporate this into this? Well, instead, let's make a polymer with a lot of little magnetic nanoparticles in it. Like pieces of iron or nickel. Then add some carbon nanotubes, which are now expensive, but I think they'll become a lot cheaper in a while if you look at C2 and CNT process. Is that these things can all have little magnets arranged around this whole thing. And these magnets, if you put a magnetic field and you have it not spread out evenly, it could shrink the whole thing. And there's a bunch of materials that only naturally shrink when you put electricity or magnets through it, through the magnetic interactions. There's a giant magnetic resistance effect, but like a lot of gadolinium would do it. I know a couple other ones. But just having this tiny magnetic nanoparticles raise light through a polymer with a conductive matrix, and the whole thing will shrink. Or it could even shake if you cause vibrations, causing it to swing more or less, or cause it to have electrical bursts, or change it from positive to negative with the AC motor. And this could all do this whole thing in this upper realm of 90 plus efficiency. Plus you get less heat loss because this whole thing will be a lot more low power. When you have something that's a little more low power, you have less problems with resistivity and heating up of the cores and elements. And heating up of the elements causes a lot of loss of energy because stuff becomes less strongly magnetic the hotter it gets, and it's hard to magnetize it. Besides that also is just a waste of electricity because electricity goes into heating, not other things. And stuff also becomes more resistive at hot temperatures. By having also the heat spread out throughout this instrument, and not only the heat coming from the motor or the gears, you can operate the whole thing so the heat is less concentrated, which means it can more dissipate quickly. And that if we have this carbon nanotube idea, It's even better because carbon nanotubes are one of the best ways of just getting rid of heat. Now with precision controlled, now this material also could maybe potentially be stronger because everything I've listed, the polymer is the weakest thing, so iron nanoparticles are stronger and more heavy. The problem with this is just it's a much more of a manufacturing challenge. So we will see in the future. But the idea I forgot to say before is that metal gears need to be made very precisely through machining and stuff, and which really limits the possibilities and makes it also not adjustable because you have to have machines just for everything and readjust it. And oftentimes when machining, you scrape off material, and this means a lot of waste material that you have to remelt down and recycle. This whole thing could be made more with 3D printers, a lot less wasteful, and you can try out many more parameters on the fly and adjust it for specific circumstances. Again, a great advantage. Well, I hope you found this interesting. Please like and subscribe, it really helps the channel out. And if you have any ideas for future videos, any comments or suggestions, or anything, please leave them in the comment section below. And I'm trying to reach 1,000 subscribers in a year and 4,000 watch hours, which is really hard, but with your help, I think I can do it. Goodbye.